Welcome to Module 4, Power Supplies and Troubleshooting Computer Problems. We'll cover essential concepts about power supplies and troubleshooting common computer issues, helping you build your skills as a student or tech enthusiast. Thanks for watching. If you find this helpful, be sure to like, subscribe, and hit the notification bell for more content. Leave a comment or share to keep the conversation going. In this module, we'll cover key objectives to help you enhance your technical skills. By the end of this material, you'll be able to clearly describe various methods and devices used to keep a computer system cool, ensuring optimal performance. Accurately select a power supply that meets the power requirements of specific computer systems. Demonstrate an organized and systematic approach to diagnosing and solving hardware issues, especially those occurring during boot. Troubleshoot electrical system issues using proven diagnostic techniques. Efficiently identify and resolve problems related to the motherboard, processor, and RAM. These objectives are designed to give you practical skills you can use in real-world scenarios. If you're finding this content valuable, be sure to like, subscribe, and share so others can benefit too. Let's start off by talking about keeping your computer cool. If your processor, motherboard, or other components overheat, your system can become unstable or even get damaged. To prevent this, use cooling devices like CPU fans, case fans, heat sinks, and liquid cooling systems. Here are 3 simple rules to keep things cool. Keep the case closed. It helps control airflow and reduces dust. Clean the inside. Dust can block airflow and trap heat. Move your computer. Place it in a well-ventilated area to avoid heat buildup. By following these tips, you'll keep your computer running smoothly. Processors generate a lot of heat, and keeping them cool is essential for performance. That's where the cooling assembly comes in. It's designed specifically for each processor to ensure temperatures stay below the maximum safe level. A good processor cooler maintains a temperature between 90 and 110 degrees Fahrenheit, or 32 to 43 degrees Celsius. The cooler itself sits on top of the processor and consists of 2 main parts, a fan and a heatsink. The heatsink has fins that pull heat away from the processor, while the fan blows that heat out, keeping your CPU cool. The fan is powered by a 4-pin connector attached to the motherboard. To improve cooling, thermal compound, also known as thermal paste, plays a key role by filling the tiny gaps between the processor and its cooling device. This ensures efficient heat transfer. Another option is a thermal pad, which is thicker and better suited for larger gaps. Thermal pads are easier to apply and come pre-sized to fit the cooling plate. However, a few important rules: never use thermal compound and a thermal pad at the same time, and never stack thermal pads on top of each other. Doing so can prevent proper cooling and damage your system. To prevent your system from overheating, you can add extra case fans. Most computer cases are designed with specific spots to hold these fans, and larger fans typically cool better than smaller ones. Some graphics cards already come with their own fan, but you can also mount a fan card next to the graphics card for extra cooling. Just make sure the fan card fits the expansion slot you plan to use. For memory modules, a RAM cooler can clip directly over the RAM and is powered by either a SATA or 4-pin Molex connector, ensuring your system stays cool and runs efficiently. There are a few key reasons to replace a power supply. First, if the power supply fails, you'll need a new one. Second, if it's not powerful enough to support your system's components, an upgrade is necessary. When building a new system, you have 2 options. You can either buy a computer case with the power supply pre-installed, or you can choose to purchase the power supply separately. Choosing the right power supply ensures your system runs smoothly and gets the power it needs. When choosing a power supply, there are several important features to consider. First is the form factor, which determines the size of the power supply and whether it will fit in your case. Next, check the wattage rating to ensure it can provide enough power for your components. You'll also want to look at the number and types of connectors, as these need to match your system. Internal fans help with cooling, and dual voltage options can be useful for international use. Some power supplies even offer extra features like a redundant power supply, RPS. which has two identical power supplies for backup in case one fails. When selecting a power supply, it's important to consider the total wattage your system needs. This includes not only the components inside the case but also any USB devices that draw power from the motherboard. Two key points to remember. Video cards are typically the most power-hungry component, and your power supply should be rated about 30% higher than your system's total power requirements. To figure out the right wattage, simply add up the wattage of all your components, then add an additional 30% for safety. Knowledge check. Which of the following is not a general rule for cooling the inside of a computer case? A. Keep the case closed. B. Move the computer to a cooler location. C. Stack thermal pads to ensure better heat transfer. D. Clean the inside of the computer regularly. Answer. Stack thermal pads to ensure better heat transfer. While keeping the case closed, moving the computer to a cooler location, and cleaning the inside regularly are effective methods for managing the internal temperature of a computer, stacking thermal pads is not recommended. The correct cooling method for thermal pads involves using a single thermal pad, as stacking them can reduce heat transfer efficiency and is advised against. When troubleshooting a system, follow these key steps. First, always interview the user to understand the issue, and make sure to back up any data before making changes. Next, examine the system, analyze the problem, and try to determine its source. Once you have a theory, test it. After identifying the issue, create a plan to fix it and apply the solution. Once fixed, verify that the system is working correctly. Finally, document everything: what steps you took, the outcome, and what you learned from the process. When troubleshooting, several resources can help you find solutions. You can search the web, use chat or email support, and explore forums. Manufacturers' diagnostic software and user manuals can also be valuable tools. Additionally, technical associates within your organization may offer insights. As we move forward, keep in mind there are 13 key troubleshooting rules, starting with Rule 1. Always approach the problem systematically. Taking a step-by-step approach helps ensure you don't miss anything important. When troubleshooting, it's essential to ask the right questions during your user interview. Start by asking them to describe the problem. What error messages, unusual displays, or failures did they notice? Find out when the issue started and what the situation was when it occurred. Ask what programs or software they were using at the time, and if any recent changes were made to the system. Don't forget to check if there was a recent thunderstorm or electrical issue, and whether any hardware, software, or configuration changes were made recently. As you talk with the user, remember these troubleshooting rules. Rule 2. Establish your priorities to focus on the most critical issues first. Rule 3. Beware of user error. It's common and can easily be the root of the problem. Rule 4. Stay calm and don't rush. Patience leads to better results. Before you start working on the computer, always back up any important data. You can do this by using File Explorer to copy data to another system, moving the hard drive to a different machine, or hiring a professional file recovery service. As you begin solving the problem, keep in mind Rules 5 and 6. Rule 5. Make no assumptions, always verify the facts. Rule 6. Try the simple things first. Sometimes the quickest fixes are the most effective. To form your best guess, start by reproducing the problem and observe it firsthand. Determine if it's likely hardware or software related. Make your best guess as to the source, and don't forget to question the obvious. Finally, Rule 7 encourages you to become a researcher. Look into the issue thoroughly before jumping to conclusions. As you test your theories, remember these helpful rules. Rule 8. Divide and conquer. Break the problem down into smaller parts to isolate the issue. Rule 9. Write things down. Keep track of your steps to avoid repeating mistakes and to document your progress. Rule 10. Don't assume the worst. Sometimes the solution is simpler than it seems. And Rule 11. Reboot and start over. Restarting the system can often resolve issues and give you a fresh perspective on the problem. When planning and implementing your solution, remember Rules 12 and 13. Rule 12. Use the least invasive solution first. Start with fixes that cause the least disruption. Rule 13. Know your starting point. Understand what is and isn't working before you begin. To fix the problem, consider multiple solutions and choose the least invasive one. If you don't have technical documentation, search the manufacturer's website for guidance. Once you've planned, apply your solution and resolve the issue. After fixing the problem, reboot the system and verify that everything is working properly. Test key functions. Can you reach the internet? Is the printer working? Can you use Microsoft Office? If possible, have the user check everything to ensure the fix is satisfactory. Once verified, ask an important question. Could this problem have been prevented? This helps you think ahead and identify ways to avoid similar issues in the future. Good documentation is key to improving future troubleshooting. It allows you to apply what you've learned, train others, develop effective preventative maintenance plans, and address audits or queries from customers or employees. Make sure your documentation includes the initial symptoms, the source of the problem, and the troubleshooting steps you took. This not only helps in the current situation but also prepares you for similar challenges down the road. Here are some common symptoms of electrical system issues. First, the computer might appear completely dead, no indicator lights, no spinning drives or fans. Sometimes the system locks up during booting, or you might hear error codes or beeps. Another red flag is smelling burnt parts or unusual odors. The computer may also power down unexpectedly. In some cases the computer seems dead, but you might hear a high-pitched whine coming from the power supply. These signs all point to potential electrical problems that need attention. When dealing with an electrical issue, here are some key questions and actions to take. If you smell burnt parts or odors, don't try to power on the system. Identify the fried component and replace it. If you hear a whine from the power supply when you plug it in, the supply might be inadequate or there could be a short. Next, check the basics. Is the power cord properly plugged in? Is the outlet controlled by a wall switch? Are any cables loose? And don't forget to check if the circuit breaker has blown. If you need to look inside the computer case, make sure to turn off the computer, unplug it, and press the power button to drain any residual power. Then, open the case. Start by checking all power connections from the power supply to the motherboard and drives. If you notice a burnt smell, carefully inspect for shorts, frayed, or burnt wires. If you suspect the power supply is faulty, use a power supply tester to confirm the issue before replacing it. Intermittent electrical problems can be tricky to identify, but here are some common symptoms to watch for after the computer has booted. The computer might stop or hang without any clear reason. You may see random memory errors, or data could be written incorrectly, leading to file corruption. The keyboard could stop working at odd times. More severe issues include motherboard failure or damage, an overheating power supply that becomes hot to the touch, or a power supply fan that becomes noisy, whines, or stops working altogether. To rule out the electrical system as the cause of an intermittent problem, start by considering whether the power supply is inadequate or possibly faulty. One sign of trouble could be a malfunctioning power supply fan. If the fan isn't working, it's crucial not to operate the computer, as this can lead to overheating and further damage. Address any power supply issues before moving forward with other troubleshooting steps. A short in the system can happen when a component on the motherboard makes improper contact with the computer's chassis. One common cause is a missing standoff, which is supposed to keep the motherboard raised and properly isolated from the case. If you suspect a short, gently shake the case and listen for any loose screws that could be causing the issue. Shorts can also occur within the circuits of the motherboard, so it's important to inspect the bottom of the motherboard for any signs of damage. Overheating can cause various symptoms in your system. The computer might hang or freeze unexpectedly, or you could experience a blue screen of death, BSOD, during boot. Another clue is a silent or whining fan, or if you don't feel air moving in or out of the case. If you suspect overheating, you can check the system's temperature by going into the BIOS or UEFI setup. For added protection, you can also install a temperature sensor that will sound an alarm if the inside of the case gets too hot. To address overheating issues, start by going into the BIOS or UEFI setup and checking the CPU temperature. It should stay below the maximum recommended by the manufacturer. If the system is overheating, use compressed air, a blower, or an anti-static vacuum to clear dust from the power supply and vents. Ensure that all fans are running properly; if not, they may need replacement. You can also install extra fans if your case has room. To improve airflow, consider adding a chassis air guide to direct air toward the processor, and replace any missing faceplates or expansion slot covers. To further address overheating, ensure there are a few inches of space on both sides and the top of the case for proper airflow. Verify that the cooler is securely connected to the processor. After closing the case, let the system rest for at least 30 minutes before turning it on again. Check the UEFI or BIOS setup to see if the processor is being overclocked, as this can cause overheating. If too many peripherals are installed, leave an empty slot between each card for better ventilation. Additionally, consider flashing the UEFI BIOS to update the motherboard firmware, and replace the thermal compound if it has hardened. Laptops are unique in that they are powered either by an AC adapter or a battery pack. Modern batteries typically use lithium-ion technology, which is more efficient and longer lasting. Most AC adapters can automatically switch between 110 volts and 220 volts AC power, making them versatile for use in different regions. For extended use, some mobile users prefer to carry an extra battery as a backup, so they can swap it out when the primary battery runs low. If your laptop isn't getting power or the battery indicator light is on but not charging, follow these steps. First, make sure the AC adapter is plugged into a working electrical outlet and the plug is secure. This may seem silly, but I have seen experienced technicians overlook this simple check only to complicate their lives as they misdiagnose the problem incorrectly. Check both sides of the AC adapter transformer to ensure the connections are tight, and also inspect the connection at the DC jack on the laptop. If the battery still isn't charging when the AC adapter is plugged in, the issue might be with the battery itself or possibly the motherboard. When troubleshooting the motherboard, processor, or memory, there are several symptoms that could indicate a failure. The system might begin to boot but then shut down, or an error message may appear during boot. You may notice the system reporting less memory than is actually installed, or the system may become unstable, hanging or freezing unexpectedly. Intermittent Windows or hard drive errors can also signal an issue, and components on the motherboard or connected devices may stop working. Always start by checking the simple things first before moving on to more complex solutions. To find the source of a problem, follow these steps. First, if an error message appears, search for it online for potential solutions. Next, run antivirus software to rule out any viruses. If you suspect memory issues, use the memory diagnostic tool to test for failing modules. You can also use Device Manager to check for hardware problems. Review the event viewer logs for any records of hardware or application issues. In Windows, ensure all updates or patches are installed. Finally, if the problem started after a recent change or installation, try uninstalling the device or application to see if that resolves the issue. If still unable to resolve the issue, use the Windows About window to check how much RAM is installed. If it's insufficient, consider upgrading. Then, check the BIOS, UEFI setup to ensure all settings are correct and disable any quick booting features to help identify boot errors. If needed, flash the BIOS, UEFI to update the motherboard firmware. Check the motherboard manufacturer's website for any available diagnostic software. And finally, update the drivers for any motherboard components that aren't working properly. To troubleshoot an onboard port or device that isn't working, start by verifying the issue isn't with the device itself. Then, check the BIOS, UEFI setup to ensure the port is enabled. In Windows, use Device Manager to confirm that the system recognizes the device or port without errors. If needed, update the drivers for the device or port from the motherboard manufacturer's website. You can also use a loop-back plug to test the port. If all else fails, disable the port in BIOS, UEFI and consider installing an expansion card as an alternative. To further narrow down the source of the issue, consider the following possibilities. First, if performance issues persist, suspect a failing hard drive and run diagnostic checks. Next, overheating could be the cause, so ensure proper cooling and ventilation. Finally, verify that the installed processor is fully supported by the motherboard, as an incompatible processor can cause instability or failure to boot. Many continuous restart errors can be resolved by running the startup repair process, which restores essential Windows files for a successful boot. To run startup repair from a Windows setup USB drive or DVD, follow these steps. First, if needed, change the boot priority order in BIOS, UEFI so the system boots from the optical or USB drive. On the setup screen, select your language and click Next. Then, click Repair your computer, and choose Troubleshoot. Finally, on the Advanced Options screen, select Startup Repair to begin the process. Knowledge check. Which of the following steps should be performed first when troubleshooting a computer problem according to the general approach to problem solving? A. Test your theory about the problem. B. Interview the user and backup data. C. Plan what to do to fix the problem. D. Verify that the problem is fixed and that the system works. Answer. Interview the user and backup data. The general approach to troubleshooting includes several steps to ensure an effective resolution of computer problems. The first step is to interview the user and backup data. This involves gathering information from the user about the issue and backing up any important data before making changes. This step is crucial for understanding the problem and protecting data. Testing theories, planning fixes, and verifying the problem resolution occur after this initial step. Now it's time to assess your understanding of the key concepts from this module. Take a moment to rate yourself on a scale of 1 to 5 for each of the following, with 1 meaning not confident, and 5 meaning highly confident. If you score less than a 4 on any topic, be sure to review that section or seek out additional material to improve your understanding. How confident are you in describing various methods and devices used to keep a computer system cool? Can you accurately select an appropriate power supply that meets the power requirements of a specific computer system? Are you able to demonstrate an organized, systematic approach to diagnosing and solving hardware issues, particularly those during boot? How well can you troubleshoot electrical system issues using established diagnostic techniques? Can you efficiently troubleshoot issues related to the motherboard, processor, and RAM to identify and resolve problems? This self-assessment will help you identify areas for improvement, so don't hesitate to revisit sections as needed. That wraps up Module 4, Power Supplies and Troubleshooting Computer Problems. In this module, we explored various cooling methods for computer systems, how to select the right power supply, and a systematic approach to diagnosing and solving hardware and electrical issues. We also covered how to troubleshoot problems with the motherboard, processor, and RAM. Thank you for watching. If you enjoyed this content, be sure to like, subscribe, share, and drop a comment below to keep the great content coming your way. Your engagement helps us continue delivering valuable tech insights straight to your feed. And remember, stay powered up, troubleshoot smart, and keep your system running cool.